Okay, Bismillah Rahman Rahim. So today we will be discussing about the GIS. So theoretically, I will just go through some slides. I will not go to in depth through these slides. I will just give you some clue about the GIS concept. So basically, in a GIS, what we'll do in this project for Mansera report. So first of all, when we start modeling in a GIS, we do a digitizing in GIS in order to draw junctions or pipes and some other stuff like that. So basically, digitizing is showing the real features in the different format in the software, physical reality in format and store in the digital computers by entering a number. It is just like to save something spatially and then save also information about that in a spreadsheet on an attribute table in a GIS. So what we will do that we will create junctions and pipe and uh, converting the physical reality into a model, and then we will give you some give you some the information related to it. For example, for a junction, we will assign elevations, and for a pipe we will calculate the length of these lines or pipes. So basically practically we the in GIS, when we draw a model in a GIS spatially, then we will assign we'll use in a spreadsheet on an attribute table. So digitizing basically taking a digital photograph of an object and identifying features of interest. So we will download or we will use an imagery file, and based on that imagery file, we will draw junctions and a pipeline. So it's basically digitizing and tracing a paper map into a digital format and identifying features. So digitizing may be defined also may be defined as for example, if you have a house and you have a road and you want to show that in vector format, so we trace above that imagery file and then convert it into the vector format, recording or measuring a physical quantity. So similarly, geocoding is just like we do a survey on a ground, taking a points on a ground and calculate its graphic coordinates and save in the Excel format, and then it converted into the spatial in GIS. So geocoding basically the showing the real features, having some address in the form of graphic coordinates and then show it in a GIS. GIS basically consists of different layers. So we will be using imagery and the vector layers and the pipeline layer and the junctions layers, and then we will overlay over each other in order to get some information about that. So basically, GIS is based on the overlaying different types of layer over each other and get some information about that. Spatial data and attribute data. So spatially, we will create a junctions, pipes, and then we will assign a specific data according to it. So data about an entity that refer to a specific location or map is the spatial data. So specific location for our junctions will be shown spatially, and data will be assigned to that accordingly. Any other non-spatial data about the same entity is called attribute data. So both spatial and attribute data are usually in the same layer. Attribute data is usually in the form of relational database. So relational database is basically this, that attribute table where the entities and their information about the spatial data, for example, for a point, for a line, or for a junction, and similarly for the line or a pipe, the information are assigned to these specific spatial uh, digitized elements in the GIS. So columns are called fields and the rows are called records. Key fields have a unique values used to identify a certain record, may be used to connect different tables about same data. So if you have a key field, so basing, for example, if you have a key field that a specific value, then that's field value we will be used for a spatial yarn. So I will be showing you that when we assign a demand, then how you will use the spatial join command in order to assign value spatially from one layer to another layer. Field data type defines the type and size of the data will hold. For example, in a field you can assign a text or a numeric value in numeric in a different format. Maybe it may be in a whole number, or it may be in a decimal, or it may be something like long dat. So these are the different format in which you can add the data to the attribute table. So the important concept about the GIS is the basically the map projections. So these are the different projection where we mostly when we work on a platform, then we project a map uh, on that platform and start to work on it. So we need to take information from irregular three-dimensional spherical object, the Earth, and transform that information accurately as possible to a two-dimensional flat surface. So basically, in projection, we transform the spherical surface into that the two-dimensional flat surface. A projection, each type of projection method use a different way to transform the solid geometry into plane geometry. So when we transform the spherical surface into a plane geometry, so the distortion in a area, shape, distance, and directions occurs. So there's a different type of projections like planar, conical, cylindrical. So a planar is just the bypassing a tangent through some point. So bypassing a tangent through the polar or equator and in a obliques with some angle. So the where the point touches the, for example, a plane like a page by passing through some point. So at that point where the plane will touch the earth or the spherical surface, no distortions will occur. Or as we increases through that tangent point, the distortion in area shape will increases. Similarly for the conical, at the point where the conical surface will touch the spherical surface will show no distortion as is move away from that touching point, the distortion will increases. So in these are the cylindrical projections, mostly the UTM projection we will use in the for the modeling of water supply network. So our earth surface is placed in a cylindrical surface, cylindrical element where in order to project the earth surface on that cylindrical surface. So the cylindrical surface passing through the equator will show no distortion, while at these polar side, the distortion will be increased. So these are different type of projections in the transverse on oblique way. So by using conformal projections, better accuracy with angle, shapes, and directions, when we use the equivalent projections, so equal area projections have a true area measurement. So for measuring of area, one should use the equivalent projections, or if you want to measure a distance between 2 points accurately, so the equidistance projection should be used. So these are the different type of projections. So I will give you that this file, so just read it, nothing to explain more in much detail. So I want to show you just specific things in this presentation. So mostly we will be working on a vector data or a raster data. So spatial data describe the location and the dimension of a geographic entities with reference to a map space representing the real world. So location basically line or the point or the polygons. So the location can be represented spatially in a GIS. Similarly, if a line and if there is polygons or dimension can also be expressed in that as well. While point mostly we point for the location purposes we mostly use the point we having no dimension. So there are two types of model, the vector model and the raster model. Basically, points are designated as a pair of XY coordinates. So XY coordinates or earthing, northing, easting, or northing are basically used in order to show the location of a point or specific location on any uh, on the Earth surface. A line is basically designated by two or more points. By connecting these points with each other, a line is obtained. And similarly, the closed area designated by the polygon, basically the closed area enclosed by three or more points connected to each other. So basically, points will be used for the uh, junctions or node for denoting of junctions, and line will be used for the pipes, and polygon will be used in order to calculate the area and that area population and that area, and based on that population we will assign the demand to each node. So basically this is a water supply network. The line shows the pipes or the sewerage network. Similarly, the polygon shows the area uh, assigned to these pipes or the demanding areas to these pipes. Similarly, the point shows the location of these specific areas: Danishabad, Jangirabad, Sufed Dairy. Okay, the raster is basically the grid form basically it is in a grid format having a pixels, and this model is divide a map so space into a regular grid of cells, usually square or of identical size. So basically raster have a in the grid format having a same size of cells. Each cell shows unique value. So higher the resolution, smaller the means the smaller the size of that cell, having a high density of a raster, showing greater detail of the earth in the raster format. So it is usually represent photographs or remotely sensed images. A resolution of image is defined by the size of the cell on the ground. If you convert the vector into the raster model, so it will be shown like that in the form of the cells. So what we do in a GIS, we combine different types of layers like a vector or raster over each other in order to get some information. So the raster image overlaid by a vector street map. So this is a raster image, and the road is shown over here over that raster map. So street map is created by digitizing the raster map image. Notice the errors in digitizing the street line passing over. So basically, when we digitizing the raster or the real features, the physical reality, so there's also uncertainty. There's certainty in order to have some errors in that digitizing specific physical reality. So there's basically the in coordinate system, the in Earth sphere is basically divided into 360 degrees along north and south. Along north and south, it is divided into 360 degrees. Similarly, along east and west as well, each degree is divided into 60 minutes. So basically, this is a 1 degree, and each degree is then divided to 60 minutes, and then each 60 minutes is divided into 60 seconds. So the system forms a grid of squares called graticule. So the squares formed by these lines connecting to each other is called a graticule. So this is the projected coordinate system. By projecting this into the, so it is showing the image when we project the sphere into the projected format. So I want to show you the basically the projected UTM world. It is basically we will be using the UTM coordinate system. So here is the Pakistan. So mostly in Pakistan, the UTM coordinate system basically divided into 60 zones, and each zones from, for example, this is 60. So each zone consists of having a 6 degree of difference. So the difference from here to here will be a 60 degree, and from here to here will be the from 6 degree, 6 degree. So each zone having a difference of 6 degree. So by using that zones, we will be assigning a specific coordinate system according to that zone. So Pakistan mostly lies in the 41, 42, and 43 zones, and at the north So this zero line, above this zero line is basically showing the north, and below this line shows basically showing the south. So how to find the zone for the specific area? So I will show you that inshallah in ArcGIS. So how to find, for example, where are you and where to you want to model a water supply network, and how you will determine that in which zone you lie. So Pakistan is basically lies in a north region, according to this UTM projection system. So first of all, I want to show you how to download a data from using a watershed modeling system. In order to download the watershed modeling system data from the watershed modeling system, when you open it, first of all, open the hydrologic, then open the hydrologic modeling wizard. Then if you want to give some name, then you can give it as well. Save it. So after defining a name for the project, you will define the project bounds. For example, where you want we will be working on the UTM zone 43 north. So how to find that projection? First of all, you will select the defined project bounds. After that, you will define the projection, and that you will set the projection, and you will go through the projected coordinate system, and this you will find the UTM, and UTM by going to the WGS 1984 northern. We are in northern hemisphere, and then go to the specific zone. So how to find that specific zone, I will show you. So we will be using UTM zone 43 north, and keep the meter unit as the meter. So remember that the UTM zone is basically measuring the x and y coordinates in a meter, and this basically, that meter is basically the vertical unit, the z units, the elevation of any point on that surface. So after defining a projection system, you will define the boundaries for which you want to define the imagery. So basically, this software I want to show you in that how to download the imagery in a simple way, and the surface because and on that surface we will be using that surface for the elevation assigning to the junction. So I want to show you that how to download the imagery and surface as well. But when you want to design a water supply network, you will be using a specific or accurate survey data, and from that survey data you will be calculating the surface. So I will also show you that how to calculate the surface when you get the survey data. So first of all, you will define the boundary. So I think Ahmedabad is lying in a 43 north zone. So I will download a data for the Ahmedabad. So just click on OK, or if you want to search, or you want to if you know about the latitude and longitude of that area, so you can jump that to location as well, and you can search here as well for example, if you want to find for a Swat or for a Gilgit and something like that. And you can also change the maps here. For example, is the imagery clarity. I will zoom that. So basically, it's took the point of the top left, top right, and the bottom right and the bottom left coordinates of these corners, and based on these corners, it will download the data. So by going next, so we will enable this option, use web services, and after that you will go to the download data dialog. So here you will select the world imagery for downloading the imagery and worldwide elevation data in order to get the elevation data. So this basically, if you want really to want the water supply network, so don't use this, because you will have to use the actual survey data, and from that actual survey data how to find the surface. So I will show you that as well. So you can also browse at to specific location. So I want to download it that location as I defined earlier. So download data. So click on download data from it will automatically download it. So it will show you that which the raster cell size. So it is good enough to download. So click on OK. So the world imagery will be downloaded. Similarly, you can in a varieties of resolution, you can also download the imagery. So 4-meter resolution is good enough. So the data has been downloaded. So now what we will do, first of all, I want to show you that how to load that data in our WaterGem. So in order to load that data in a WaterGem, and also save that data, mostly this I'm showing that how to load the DX format, and I will also show you that how to create a DX format from the survey data. So save as the DXF format. So the WaterGem basically supported DX format for the surface file. So if you get the data in an Excel format, and how to import that into the GIS, and based on that how to convert that Excel data or that data into shape file, and from that how to convert that into the DX file. So I will show you that in a while. So here I'm just exporting it as a DX format to elevation data. Save. I will import the. So if you want to import that specific surface layer, so you will click on the background layers, new file, and after that you will go to that specific location, click on the DXF file, open, open. So you get that the surface file. So how to load the imagery in this WaterGem, I want to show you that as well. So after opening a WaterGem, you will create the new map. After creating a map, change the coordinate system of that map as well. So right click on the map properties, and then scroll down, projected coordinate system, UTM. Okay, before to find the coordinate system, I want to show you that how to find the coordinate system of specific region. And if you want to change the map of that world hill shared world topographic map, you can change that from base map as well. So clarity, street map. So there are a lot of options you can choose by your choice. So if you want to find the coordinates system, the UTM coordinate zone, so click on the coordinate conversion. You can find that in the map tab, coordinate conversion, and click on this map point tool, and then click on the anywhere in that specific area. So it will show you the 43S. So S is basically the vertically grid showing these in the alphabetical order. So don't use this S T U V alphabet. Just you can easily see that the Pakistan is lie above that zero line, means it is in the north region. So only consider this 42, 43 value. So it means that the Abbottabad region is lying in the 43 north. So always use north anywhere. If you find, you will always find, if you want to design any type of if you want to work in any region of Pakistan, so you will always find 41, 42, and 43. So whenever you find 41, 42, 43, just use these specific values and add a north with it. So we are in the 43 north zone. So therefore, based on that, I will convert my map into that specific project coordinate system. So projected coordinate system, scrolling down, UTM, WGS 1984, Northern Hemisphere, and the 43 North. After projecting the map, I want to add the imagery file which we have downloaded earlier. So to add that file, first you have to connect your ArcGIS Pro to that folder. To right click, so click on the catalog. If this dialog is not showing, so you can add it from here, catalog pane, and then right click, click on the folder, right click on the folder, add folder connection, make a connection with that folder. So lecture add GIS folder. So it will make a connection with this. So here we have an imagery file. So just click on drag onto the workspace. Click on no. So you will get that the imagery for that specific region. So you can observe that we downloaded that for that specific Abbottabad region. If you want to check, you can check as well by changing it to the image clarity. So you can observe these two maps overlaying over each other. So basically, I want to show you that how to load that specific imagery into the WaterGem. So to load that imagery, you have to first zoom to the top left corner of that imagery, and then click on the coordinate conversion. You can add any type of system from here just by clicking this XY plus sign add. For example, if you want to add another DMS, degree minute second system, so you can add as well. So I want to calculate the UTM coordinates of this point. So if I click here, so it will automatically loaded that coordinate and convert it into the UTM coordinate system. So I want to clear it first. So I will just try to select accurately that specific top corner. Click on the list of coordinates, you will get the X value and similarly for the Y value. Now I want to load that specific imagery. Click on the background layer's new file and then click on the imagery and then disable this use compression option and use trilinear bilinear as your choice. Change a unit to a meter, and always if you want to start a work on WaterGem, try to convert your unit according to the imagery or the surface you are importing to the WaterGem. So change it to the SI reset defaults. So after changing it to the SI unit, I will import the imagery file. I will use a trilinear. Disable this option. If you enable this option, it will crash and the WaterGem will shut down. So don't use compression option. So we have calculated the for X and Y coordinate for the top left corner of that imagery. So I will just copy from here. You can dog and you can auto hide this from here, that specific window. Just copy this and paste it here. Okay, I'm sharing another link because the time is going out.